Test. Seems to be live. Hello everyone. Welcome to one more stream of the Compiler project. As you can tell by both my appearance and my voice, today is gonna be a somewhat low energy stream. My health has been pretty bad over the last year and a half, and sadly, it's making sometimes this project a bit more complicated than it needs to be. So today is gonna be. No, wait, where's their desktop audio? No, it's fine. Okay. So yeah, this evening is gonna be a bit difficult. So I'm gonna make as much progress as I'm able to make, and that's gonna be better than nothing. And yeah, that's about it. So last week we did a lot of progress on the analysis thing. I tried something which is akin to what GHC does for the processing of a module, which is we want to be able to process declarations in the module in any order, despite the fact that they might depend on one another. So we do a shallow resolution of each top level declaration before. Thank you. Before moving on to the actually fully resolve each declaration. I've been thinking about this, and there's a few edge cases I've been able to identify in which this logic of we do the shallow resolution and then we move to the deep resolution isn't gonna really work out. So I think I'm gonna change something, and what I'm gonna do instead is we're gonna maintain a second map of like this is a fully resolved thing, and then we can look for definitions. And there's another cache, which is like the non-resolved thing, the source things, which means we're looking for the type of something. Either it has already been resolved and we can just look for that, or it hasn't been resolved yet, and we can then start resolving it in order. The only problem is going to be loops, but the loops only happen in situations that are problematic. There is a lot of way to resolve types without fully resolving something, and I think that's the nuance there. When we do type checking, for instance, from a function, we don't need to fully resolve the functions it calls, just get their types. So basically, rather than doing this shallow pass first and then doing the deep version, we immediately do the deep version that may require a shadow evaluation of other declarations. This requires making sure we do analysis of cycles, but we needed to do that in the first place. So I think this approach will be a tiny bit better. So let's try to do as much as we can this evening, and worst case, we'll continue next week. Okay, so that means here we are gonna have to change a few things. I am not gonna continue. Everything about the initialization of the context is gonna stay the same for now. However, I might be tempted. I'll see about this. I might be tempted to change something here, and I think I will, but maybe not this evening, which is currently I'm using the read-write state monad, which allows me to carry a reader state, a reader info, a writer stuff, and the state stuff. Reader is everything that's accessible at every step, but cannot really be modified. Writer is the side output, in this case diagnostics, and the state is the thing we're modifying along the way. I think this context thing does not belong as a state. Or if it is a state, it should be a stack of states. Because basically we're gonna want to be able to say, oh, within this function, the name x is overridden to mean the argument to the function. Well, outside of the function, it might mean a constant, which is in scope. And if we have a for loop in which the variable is named x in a function that has a argument named x in a module that has a constant name x, then we need to be able to stack all of those x's. So we're going to need to have a stack of contexts. But a better way than having a stack is to put that in a reader and actually use local, the function that modifies the reader state, for lack of a better word, only for the recursive call. And I think that's the approach I'm gonna want to take, because that's the one that removes any state handling from our side of the code. We just say local, here's the modification, and execute this code with the change to the stack, with the change to the context, basically. So this is something that we might not address this evening, depending on how much progress we make, but that's something that I think I will want to change. So, back to here. For now, I'm gonna leave this unchanged because we did a lot of tests last time and this seemed to be working like the way we expected. Again, there's that change in the scope and context that we might want to do, but for now this is fine. What I am gonna change is we have those shallow and full declaration, and I think that's no longer something that we're gonna want to keep. What I'm gonna change as a result is those declarations here, which are going to be part of the state, because those are not going to be like changed based on the scope. What's going to change based on the scope is the name. This identifier that we have here, what actual thing does it point to? But given a name, something that uniquely identifies a construct, what is its declaration is something that's not going to be changing based on the scope. And here, the challenge I had was the declarations within the module are not resolved yet, because that's the whole point of this phase, is analyzing them and resolving them. But here we have this map to the resolved declarations that we have from the imports. How do we make something that fits this mold from the ones in the module if we want to be able to have cross-referencing? And I think I'm just going to bite the bullet and introduce a context locals, which is the past declarations that we are going to be looking at, basically. A hash map of like, okay, here are the things in this module, here are their past declaration that we have not analyzed yet, which means when we do a lookup, we try to look something up in the like already resolved declarations. If we don't find it, it just means we haven't processed it yet. We can go to the locals, and then we can start recursively doing the things. If there's no cycle, everything will work just fine. If there are cycles that are fine, such as, for instance, a recursive function where we only need the type, then we can perform a shallow analysis of that past declaration and not actually fully resolve it and put it in the new resolved declarations. And there is one context where we're going to need to be able to detect cycles, which is type aliases, where if a type alias depends on another one, or maybe for some constants as well, we're going to need to be able to identify those cycles. So we're going to need one more thing, which is going to be... Do I call it a stack? That feels slightly inaccurate, but that's fine. Which is probably just going to be like a set of names. It could just be the hash set of just the identifier, like the top level names of... Yeah, I guess it could just be the top level name. Something like that. That means that we're going to need to make sure that we already have made hashable. That's perfect. Okay. So that we can keep track of like, hey, we were trying to resolve type alias X. It points to type alias Y, which points to type alias X. Whoops, that's a cycle. We detect the cycle because the thing we're trying to resolve is already in the stack. And we can identify that and emit an error and avoid having the compiler just recurse forever. We are going to need to change a few things. So here the context is going to require... I think I'm going to keep, for now, for this evening, I am going to keep the same logic of we start with an empty state and we just initialize it with... and we initialize it as part of the start of the analysis. And this is gonna be, I'm gonna need the hash set in scope. I could use the fact that all of those have like monoid instances and just use MMT, but I like to be clear like this. Okay. That's it for this module. Let's go back here. So a lot of this is gonna change. Let's go back here. So init local names init local names is this resolve shadow, which we are gonna be changing. Oh no, that's sorry, that's just initializing the names. Do I want? We probably want at this point to just initialize the declarations because we have them, I think. Except here we were discarding the declaration in favor of the location. I guess that means we just need to add I guess we just need here to keep the entire thing, which is a with location declaration. So here, this is an annotated declaration. And here, therefore, we are going to need that is not correct. This is annotated declarations, so we're going to need to do a map location on those locations. There we go. And here we can do this. So top level names is this thing here. And make paths. There we go. So that's just inserting the name. And we can do something here. We can also modify, how is it called? It's called context locals. And in this case, we should not need to do this. It might be enough to just set the thing because the locals are not going to be defined ahead of time. The built-ins are not part of the locals, so we don't need to merge with any existing map. And this is going to be, I guess, just removing the location from each yes, this is going to be for each identifier and annotated declarations in the list. We have already handled, this is a non-empty list, so we have the guarantee that it's non-empty. We have already handled the case where any of them is greater than 1, so this is always going to be empty. We never need it. So this is the top level names list, and for each of those, actually it's a tuple of the name and the declaration. There we go. And top level name is a hash map, so we're gonna need to do a to list back on it. Oh, well, we're gonna from list to list. Could we just... Yes, this is already indexed by identifier, so this is a simple map then. So I don't need to do all of that. This is top level names on which we take... Actually, no, it's... We are changing the key as well. Where we had something indexed by identifier, we're changing to make it indexed by name. So I guess doing this thing where we deconstruct the previous hash map and construct a new one is probably the easiest. And we return something, which is the name as the key and the unannotated declaration as a value. Okay. So now the locals are set. Here we have this shadow declarations of traversing this, and I don't think we need to do that. I think we need to simply do that. An analyze declaration is going to be our top level entry point that delegates the thing and does the full analysis and delegates if needed to another, like delegates recursively. Okay, let's try that. Resolve path. You're wrong in many ways, but I'm going to keep you for now. I'm going to remove shadow declaration analysis for now because a lot of this will overlap with what we need to do anyway with the real declaration. So I'm just going to keep this instead. Now, what do we need to do here? What we need to do is check. This is going to be our entry point. So what we need to do is simple. Let's look at the cache to see if we've already analyzed a given declaration, because we analyze a function that depends on the type that is within the same module. We analyze the type recursively. Actually, is there ever going to be a point where we need to do a full analysis of the thing? I guess for type aliases, getting the type info is doing the full analysis. So that means, yes, there are situations where we are going to go for something and it's already going to have been analyzed. So we can just do, this is going to be a use context declaration. And the function I'm applying on the context declarations is a lookup. So I'm going to need the name of this. And yes, okay, so this is going to be that, and on nothing. So if this returns just a value, we use that value as the result of our function. If it's nothing, we open a do block and we perform this. Okay, so the name will be given as an argument. No need, because I will always need the name of something anyway, so I think this is fine to use it that way. Okay. So here, that's the part where we're trying to do we should have already resolved the shadow version. That is no longer a thing. So this is where we're going to do the actual analysis, which I guess will be delegated to a sub function. So it's going to be probably something along those lines. Resolved declaration. It's going to depend on what the kind of declaration this is. We get the resolved declaration. This is the function that does the full analysis, which means at the end of this, we can context declarations can be modified to do an insert of this name, and the value is the resolve declaration, and we return pure of that resolve declaration. There we go. With one exception. Do I want to handle... Do I want to handle the stack of full declaration here? I think it's the easiest, because that way every time I need... Yeah, I guess I can just handle this here. So here we are trying to resolve the declaration of this particular thing here. So what we can do is modify our context stack. It's a hash set, so it's just going to be an insert of the name. And actually, before we do that, uses context stack with... So in our shared state, I'm looking at the context stack and I'm applying the function, is this name a member of the set? Cycle. And that gives me a boolean, which is, are we in a cycle, basically? If cycle, then this is going to be, we've made some functions for this, report fatal. And we don't have a diagnostic for this. Error, cyclic definition name. And error cyclic definition this name. Otherwise, we did not find the information in the cache. We did not... We are not in a situation where we have a cycle. We need to signal in the state that we are processing this thing to be able to detect cycles in the future, which is this context stack already, so that's done. And in the end, okay, so that should be fine. Okay, so now we can rewrite. Here, analyze declaration requires the name. I guess I could, after getting this local declaration thing, I could get the hash map that associates name with local declaration, which would be a use context locals. And the result of this is a may-bt of a sequence of a do block in the list monad. And for each name, for each tuple of local info in toList of those local declarations, uncurry analyze declaration of the local info. Actually, Actually, no, let's do this slightly differently. Let's go back to this, basically. This is gonna be to list of the local declarations. I traverse with runmaybt of uncurry analyze declaration. So uncurry will mean when we do the toList here, we get a list of tuples, of pairs, key value. And this function happens to be taking two arguments, which are the key and the value. So we're transforming this function of two arguments into a function of one argument that takes the pair. And that gives us this, and we can then do that like we did before. Okay. So again, not touching any of this. Init local names, init imports, that seemed to work before, so I'm not going to change it. And now, analyze declaration is our root thing, and we are going to be able to delegate to for each kind of declaration to another function that does the analysis, rather than trying to make everything fit here, because that's going to be a bit tricky. So let's start with I think, one of the most complicated cases, surprisingly. I think all of them are actually complicated, but let's start with this one. So this is going to be taking... Do we need the name? Do we need the name? Probably. And we get the type alias info passed, which is the declaration as it was in the source code before analysis. And if this all works out, we written a maybt of the analysis monad. And what we're going to return is just a declaration. Actually, we don't need to do the declaration resolved. We can just return a type alias info resolved. Okay. So we have this name. And we have a path info. Now here we are in the context where we need to fully resolve this thing. So we can go back to what we had here, this resolve path, which was slightly insufficient, because it's going to be the basis for our resolving the type alias, because a type alias is, if we go back to the AST, it's the name, we have the identifier, we have the parameters, which is like a alias of like a vector of t would be, for instance, I don't know, some kind of structure of with parameterized by the same v or something like this, or like a map key value would be a vector of tuple key value if we had tuples, something like that. So that's the name of the arguments. And this is the actual value. That's the thing that points to the actual type that this thing points to, that we need to resolve, because it could be itself a type alias. So we need to fully resolve that and check and like resolve the type arguments as we go. Which means we're gonna have to figure out this stack of local context immediately, because we're gonna need that to be able to resolve the arguments. Okay, so I guess I already need immediately to figure out this thing about the stacked scope, because we are going to add new things in scope, namely the argument names. So if there's an argument name t to that type alias, we need to be able to know that this t refers to the top level type variable. So if we change the names here to be part of the reader, I think that's the thing that makes the most sense. We can try to do that. The name info becomes absolutely terrible, but we can fix that later. So this is the one that starts with the built-ins. Okay, so what we're going to change here is when we create this, rather than setting context names, we are going to need to return that so that the top level function can do, okay, with this scope added to the stack, let's do the rest of the analysis. So this function here cannot return context names here. It needs to return that, which is a hash map from path to name. So here we are going to update the state. That part stays, but then we return this to the top level. And here, likewise, at the end, the names cannot be added to the state because we no longer have a state. We need to return this as a new I'm just gonna keep this commented out, because the way we're gonna merge the different maps is gonna be important. So I want to remember how we did that in the past. We are gonna be returning this, which is likewise a hash map path name. So here we were using just simple map union. And I think the reasoning is there cannot be imported things with the same name as a built-in, and therefore there's not going to be any conflict. I guess that makes sense. But here we were doing union with union of the keys, of the values, sorry, not just union on the keys, because we wanted to be able to handle conflicts. For instance, we want to be able to say, oh, are you referring to the name foo declared in this module or in the other module that we have seen before? Okay, so now that means here at the top level, this gives us foreign names. This gives us local names. And that means here we can do the local change to push something on the stack for the declarations. That's going to change the names in the reader. And the modification is going to be I guess this is going to be union with the union of those two maps. So I can rewrite it as unions for that to be very clear. So it's going to be union of the existing one. Actually, I want to do it that way so that it keeps... I'm going to introduce here combine maps, which is going to be union with... And so I can write this as combine foreign names, combine local names. Combine maps. Okay, so now we've changed our thing to use the reader rather than the state. And that means we can go back here to our type alias. Just gonna keep the AST here for a second. Just gonna copy that. Downside of working with one very zoomed in buffer. So now we can add the name of those parameters to the scope. So if one of the arguments is named t, then any reference to t within that thing will be pointing to the type argument, which means we're going to need a new name. There is now a type of name, which is type parameter. And it's just an identifier, I guess. And so when we analyze the type alias, we need to collect the parameters. So that's going to be new type names is going to be a hash map that we obtain by getting each identifier in the list of the alias parameters. And for each of them, we associate to the identifier. We associate to the identifier the name, which is type parameter of this identifier. I'm not even sure the identifier needs to be here. If it doesn't, we'll just remove it. So now we have this new map. What we need to do is, for the context of this evaluation, we need to have those names take precedence. And that's just... Oh, there's one mistake I've made. I see, which is here, my local... applies... It treats the reader as if it were only the map, which is not true. Is there, in control monad reader, is there a version of local that takes a lens to the thing that we're trying to change? No, local modifies the R itself. Okay. That's fine because we can do it with lenses. The thing we're trying to do is it's called, how is it called again? Info names is being modified by applying I always want to combine with it doesn't the order of the arguments doesn't matter because I'm doing the union on the values. So I am doing I'm modifying the names by doing combine maps for names, combine maps, local names. There we go. And here, in the type alias analysis, we do the same thing. We modify the info names by doing here, I'm just going to type it out because I only have to type it once, union with this. No, actually, that's wrong. This is just a regular union because we want to override if there was something named another type named T in the same module, we want to override to say no, actually T refers to the argument to that thing. Okay. And now that we've done that, we have the names in scope and we can analyze the value, which is basically this resolve path thing that we are going to need to copy. So I just need to check something, which is lens reader. It's getter. What's the, is it views? If I want to look at something in a reader and apply a function. View, and is there a views? Okay, that takes a function as well. Perfect. So this would be views. And it's called now info, is it? I keep not remembering. Again. Info names, yes. So, we look up the path name. And if it's not found, that means there's no name that corresponds to this type. I guess it could just be there's no reason for it to not be. It could absolutely be the type itself. Like int map of t could be t parameterized by int or something like this. So that's fine. If we find more than one possible name in the scope, that means the name is ambiguous. Actually, this is, do we want the types to override? I think we want the types to override. I think if I have a type alias that has a type parameter named t within the expression of the type alias, even if there's a type in scope named t, then it isn't ambiguous. It maps to the actual argument. It's a shadowing, maybe, and maybe we could emit a warning there, but it is not ambiguous. So I think here using the regular union and overriding any previous name is correct. But we should probably here to do emit warning if type name shadows existing type. Okay. And so now I have a bunch of arguments to this, and I am going to need two. Each of them is a path info. Wait, that is incorrect. Let's go back to our AST. I haven't changed to this last time. I was it again. What is a path info? It's this. So I guess this is actually resolving the path info. And not resolving the... This is a type alias info, not a path info. Okay. So that suggests that we need a resolve path info, which could be local. I don't see why it would need to not be. Actually, no, I'm gonna get some path info we need to be able to resolve at another time. So let's introduce resolve type path info, which I guess is this basically. So this is exactly what we have copied here. Is there anything I want to change? So yes, here this is views again. None of it has changed. So with the local, what I'm going to do is simply a resolve path info of the alias value. Which gives me the new path info, which is the only thing we have to change. Resolved. And the result of this will be a type alias info with the same alias name, the same alias parameters, because those are not things that need to change based on the analysis, and the resolved value, which I could almost rewrite as an fmap, basically. But I think I prefer it to be clear that way. Okay. So now we can keep this. Is there anything missing here? Yes, this is insufficient. This is insufficient because we could very much be in the case where we have resolved the path info and we have obtained a new name, which is itself a type alias to something else. Which means I think when we get to that point, I kind of want to change something. I kind of want to change analyze declaration to just take the name and do the lookups for me. Is it in the cache? No. Therefore, it must be in the other thing, because otherwise we need to do the lookup ourselves all the time. So I kind of want to change that. So I can here say, well, here's a possible name. Tell me what this is about, basically. Because what do I want to figure out there? Basically, what I want to figure out is if this name is itself a type alias, we need to continue resolving. If it's not, we need to check the type arguments. That's the gist of it, I think. I think there's not much else we can do at this point. That being said, I think it depends on what we're trying to do. I think this resolve path info will be different based on whether we're trying to... So maybe resolve path info does one level, and but that's not great. That's great because the arguments were going to have the same problem. So it depends on whether we're trying to resolve a function name, or if we're trying to resolve a value, or we're trying to resolve a type, I guess. I'm kind of tempted to just duplicate, like make this specifically for types, and then duplicate this function when we get to values. And worst case, they have a lot of overlap, and we can see afterwards how to deduplicate them. Okay, so we need a type. So this is going to be resolving a type then. I had started doing something like this. Yep, there we go. So, here. Here we have obtained the name that corresponds to the identifier pointed to by the type. So for instance, if we're saying username is user info is some other type with some type parameters, we have resolved the first name. Now what we need to do is check its declaration, because if it's not a type, that's wrong. So we need to obtain its declaration. And I guess this is the context in which we are going to need to do. Let's do a retrieve declaration based on the name. And retrieve declaration based on the name. Actually, it's probably just not going to be a with location. It's probably just going to be a declaration passed, I think. Oh, wait, that means I can't do the location. Okay, it is going to be a with location. Okay, so retrieve declaration for a given name. What does it do? It tries to get it in the resolve declarations. And otherwise, we have to get it from the locals. So it's going to be uses context locals. And here, local, if it's just local declaration, then we can return analyze declaration name and local declaration. And otherwise, we can throw an error of like name not found. Is this an internal compiler error? Is this an internal compiler error? I think it is. Because every single name we encounter should have... Oh, that's not true. Some names will not have matching declarations. For instance, built-ins or a type parameter. So what do we do here? I guess it's fine to just... I know that's a bit double of maybe, but this one is for short-circuiting in case of error, and this one is like, no, there has been no error, we just didn't find the thing we're looking for. So that means here... traverse with analyze declaration name. So traverse gonna go through the maybe and only perform the thing is the thing is found. There we go. And I guess I could rewrite it this way. Okay. So here, so resolve path info is where we are back. So we retrieve the declaration associated with a name. And now, I guess I could just do this. Now, what are our options? Nothing. Then there is no problem. The name points to either something local or a built-in. There's no need to resolve anything. There's a question of like, how do I want to represent the declaration of built-ins? I don't have a solution for this yet because I think I will want to have declaration for some of them because I will want to be able to check the number of arguments, basically. And when something doesn't have a declaration, then I cannot check the number of arguments. For instance, if type alias with t parameter is t parametered by int, whether the argument is correct is based on the instantiation of t. It's not something I can check ahead of time. So if there's no declaration at this point, there is no way for me to check the validity. Oh, that means also we're going to have some problems of checking the instantiation of some types. That's going to be interesting. I think there's some trickery with generic functions that we're going to need to deal with that I haven't completely figured out yet. Specifically, I think we're going to need to do basically instantiation of functions and types for each type argument we encounter. Does that mean we need to create a symbol map that contains copies like per module that we build? Like we're going to have to figure out incremental compilation. There's a bunch of things that we haven't figured out yet. But incremental progress. Tonight we're making progress on doing the analysis. So I guess here, if I cannot find an associated declaration, it's fine. It just means the thing we're pointing to is a type argument or a built-in because we haven't figured that yet, and there is nothing to do here. So I guess here, what do we do? Nothing, because I guess this is purely a verification. No, actually, we want to return the actual name of the underlying type. We want to return the proper resolved name. So if there's no underlying declaration, there's nothing to check. That's just a name. That's convenient. And now we have to check for each kind of declaration that we find. If it's, and that's I think the thing we had here that I can just copy. So if we find a constant or a function, we can report an error. Like, hey, your type alias is pointing to a function or a constant. That's not a type. If it's pointing to an enum or a struct, we need to do a verification, but the name is fine. So I guess I could put actually those two below because both of those is basically check argument and then return the name. So something like name check args or something like this. And the interesting case is, so here I'm going to need the info. And this is the interesting case. We have a type info. We have a type alias, which means to get the actual proper path info, we are gonna need to resolve the type alias. What about the type arguments? What about the type arguments? Am I able here? So basically, if I have a type alias, if I have type foo equal of t equals bar of vec of t, for instance, and I try to do the analysis of this. I resolve the name bar that I know is another type alias in the scope. That's perfectly fine. We just need to analyze it recursively. And bar of t is defined as, I have no idea, but let's say map of int to t. Let's say that now this t will be referring to this t which happens to be vec of t. How do I convey this? Because now, if I just do a recursive analyze type alias, I'm going to introduce a new t in scope and say, well, this t here points to this t, and I'm going to completely ignore the fact that actually it is vec of t that points to here. Is that a problem? Or is it fine for now and becomes a problem when we have to do some resolving later? I think it becomes a problem in the sense that we want to do substitution. But I think we don't have to perform that substitution now. What we should be doing is resolving it recursively. Like, oh, we need to know that bar of vec of t is map of int of thing, and when we get the result, on the result, we can perform the substitution. I think that's the correct approach. So that means here, if we found that the type alias resolves to a type alias, then I think what we have to do is analyze type alias of the info recursively. And here we have to then perform so that's going to be the resolved info. And now we need to perform a substitution. And here, what do I want to return? Is it okay to actually just return the name? Is that correct? Or should this return the full path info, actually? I think this should return the path info because what we do with this depends on the type of the arguments. So I think the arguments should be resolved first. Like, what are the arguments I'm giving to that thing? Ah, this is tricky. Okay. I might decide to move doing the substitution to next time because I don't think my brain is working well enough this evening to actually do that. But I think, yeah, we need to do the analysis of the parameters to be able to then look at, oh, this is actually a bar. Okay, we have analyzed all of those things. We know we have resolved what a bar is. Now we can say confidently what a foo is. It is a map from int to vec of t. Oops, give me one sec. Okay. So I think, yeah, that's the correct order of things. So we resolve the parameters, then we look at the declaration. If it is a type alias, we continue replacing recursively. This analyzed type alias will detect cycles if there are cycles. Here we must perform the substitution, and at the end, we return a path info, which for now I'm going to leave it undefined and defined, which will map to the name of the resolved info here with the resolved parameters and their substitution done, basically. Yes, I think that's correct. So that's going to be the tricky one. Here, the others are fairly straightforward. If we encounter a const declaration or a function declaration that thing is the type, we can just return an error. That's easy. And otherwise, if it is an enum, enums don't take arguments, so I guess this is just checking that the number of arguments is 0, basically, that there's no type arguments there. Oh, we probably also want to check that all of the arguments are used. Do we want to do that? Like a type alias t that doesn't use the argument t? Yeah, we probably want to figure that out, which is probably when we do the type substitution. Okay. So I guess here we can do something fairly straightforward. I don't need the enum declaration. I can just simplify that. Because here the only thing we need to check is well, when not null params. So if there were arguments given to this, then by definition they're not going to be used because the enum cannot take any arguments, so the name we have there is nonsensical. How does that work with the type alias here? If we have an alias to an enum, will we do the right thing? Because I think this is slightly... Yeah, this case here is the tricky one. And I need to make sure that we do handle things properly there. Okay, let's do the simple case of the enum. So when that's the case, we can report an error, I guess. And that's just gonna be something like error unused type arguments. And that is simply going to be... Oh, but I don't know the name of the type arguments because I have only the path info that contains So do I need to do this at the type alias level, not at the resolve type level? Probably. God, this is tricky. Okay, well, in the sake of I want to make progress, I'm gonna just for now do this and delegate to the color the responsibility here of checking that the arguments are correct. I guess it's therefore here that we do the type substitution. Yeah, I think it's here. Basically, this is, I think that's the key to this. Is here we're just saying here's the type that it maps to, and here are the arguments that are required for it. But that's not that simple. No, I think there are things we can check here. But I don't know. That's tricky. Because here I need the declaration to be able to decide. I need the declaration to be able to decide whether the number of arguments are correct, but I don't have the names of the arguments in scope. Because the path info only contains the arguments in order, doesn't contain their names. I guess I guess there's two different errors. There is the type alias, the type parameter was not used, which is only here that we can decide because we have the name and we must perform the substitutions. And there is the number of arguments is incorrect, which is something we can perform here because we have the number of parameters. Okay. Incorrect type parameter count, I guess, and the name. So if we have found an enum and not null params, then report fatal, and the error is error. I just called it incorrect type parameter count. And I guess I could put that here int and int, and it's going to be expected actual or something like this. And this is the name, and the expected is length of, well, it's 0 in the case of an enum, and actual would be length of params. Otherwise, return pure the path info name params. Okay. And here, for the structure, we can do something very similar. But here, we need the info. What is a struct info? It's this thing. Okay, so here we should probably be doing some substitution as well, I think. Or do we do all that in the type alias? We might just be doing this in the type alias. Maybe this makes no sense here. So here, for now, let's just do when the length of the parameters is different from the length of struct parameters of the info, then that's the same thing, except here, I guess I'm going to say expected equals this, and actual equals this, and I can rewrite this as when expected different from actual, which is a lot more readable. Then here expected actual, and otherwise return the path info. Okay. Now, I guess we can perform the same thing here for the type alias. Type alias is the special case where we need to resolve the type alias again, but that gives us a resolved type alias info. And from that, so there's probably some substitution to do here, I guess. Maybe. That's unclear to me yet. What we can do is the same thing here. Which is the number of expected parameters is this. The actual is this. If it's, yeah, there we go. Okay. So I don't think that's enough. That's not enough. We're not yet resolving something properly and fully. Actually, that might be enough depending on how. Do we need the substitution, or is it already performed by the lookups we do here? I guess we're gonna have to try. But this should be already. That should be most of the work here. Okay. So now let's move on to analyzing a struct, I suppose. Because that should be a lot easier. Famous last words. Because I had something from last time. The shadow declaration analysis. And I think that's basically, in a struct, the only thing we have to check is the type of the arguments, the values. I guess there's more we could check. We could do some warnings, like maybe this name overrides another name from something else. Like there might be some warnings we could do. But in terms of errors, a structure, the name is already well formed because it wouldn't have passed otherwise. Likewise, from the name of the elements of the structure, the only thing that needs to be really resolved is the type of the arguments. And we already have resolve type, which will, in theory, perform everything for us. So that means that unless something is very wrong, that should be all of it. There is no need to do anything else, basically. We just need to resolve the types. The only thing is, what happens if we have a struct A that depends on a struct B that depends on a struct A? In theory, this is possible to resolve without. It is possible to resolve without it being an issue, because we don't need to fully resolve a structure, we just need to know that the name resolves to something. So we do a retrieve declaration, which does an analyze declaration. So that's gonna not work if we have a structure A that depends on a structure B that depends on a structure A, which we want to allow, actually. In theory, that's not gonna be possible. Yeah, that is. It's a problem of like this is all completely mutually recursive. The only thing is, since we are working with extremely limited language, in practice, having a structure that has a field that ends up containing the same thing, since we don't have pointers, that would be an infinitely recursive thing. So we could just not allow it. That's fine. However, we will have vectors. So having a structure A that contains a B that contains a vector of A, that's technically possible because it could be an empty vector. So it's not necessarily an empty, like an infinitely recursive data structure. Therefore, this use of retrieve declaration is going to be a problem. Hmm. Haskell is a fun language. I I don't think with this project I'm doing as good a job as I do with my Advent of Code stuff, which is like trying to make Haskell seem approachable. Here, I am. This is no longer my main focus. But Haskell is a very fun language. Here, I'm more trying to figure out how do we deal with this kind of recursion. Yeah, Haskell is extremely fun because technically, for structure, I don't need. This is where I need this distinction between shallow and full. Because I guess, yeah, I guess this is where I could try to be smarter. This resolve type here does a retrieve declaration because I need to be able to say, was this a type alias? Was this, like, what is this, basically? And I need to be able to not go, to not fully analyze the thing if it's not needed. And if a structure A contains a reference to structure B, I don't need to analyze B. I could just use the unanalyzed version of the declaration. Yeah, actually. I think retrieve declaration doesn't need to actually perform the recursive analyze because all of this works just fine on the unresolved version except for type alias, which can then perform the analysis and error in case of a cycle. Yeah, I think that's the correct approach. So retrieve declaration is going to give me a past version and is therefore reduced to just this. We are using, we're looking at the current state. We are using the context locals lens. On it, we are perform a lookup of the name. And we do not need this traverse analyze declaration. This is all that this function is. And now here, in the case of a type alias declaration, yeah, all of those others don't actually require the thing to be resolved. Therefore, we no longer have the problem. And as much as we probably would like to have an error for, yeah, sorry, I'm just gonna finish this and then I'll answer your question. Sorry, I hadn't seen it. I think as much as it would be nice to have a proper error, like, oh, you're trying to create an infinitely recursive structure that's not going to be allowed, there is a very easy solution to that problem, which is trying to create a structure that has an A that contains a B that contains an A. It will never be possible to write code that initializes it properly. Therefore, it's a problem that solves itself. And yeah, this is a custom language that we are writing a compiler for, which is a subset of Rust, a very, very small subset. It has, like, for the challenge to be interesting, including for me, because it goes a lot beyond what I've already done in the past, it has still like some interesting parts of the language. It has like type arguments. It has like, it has some amount of complexity, but it is a much, much simpler version of Rust that doesn't have pointers, for instance. And the reason for that is we are not targeting assembly. we're targeting a esoteric language named Piètre, in which the source code is an image. So we're taking Rust-like code and we're generating an image. For instance, do I have one here? This is the first image we have generated from bytecode, not from Rust-like source code. But this is a valid Piètre program that prints 2 characters to the output and just the color square language one. That's exactly the one. So this is a valid Piètre program, and this is what we're trying to generate, basically. Hence the very strong restrictions we have, because Piètre doesn't have a heap. So we can't do pointers, we can't do anything like this. We are limited to the stack. There's no float support or anything like this. So our language for now is just int and vectors of characters. That's about it. We're already done with the lexing parsing, the AST and everything. Now we're doing the analysis phase, which is type checking, name resolving, and so on, which is, I think, one of the 2 most complicated parts of the project. When that's done, when we have finished generating a resolved version of the language in which all of the errors have been eliminated, we have something that every single error coming from the user has been identified. We're going to have the second most difficult part of the thing, which is the lowering into the AR, as in taking this AST still representation of the language and making it into an intermediary representation that is something that is easier to compile. And our goal here is, again, to do something that's realistic if simplified. Yeah, I mean, that would be kind of horribly complicated, given the fact that Piètre has only some very limited instructions to access the stack. So that would mean basically any kind of thing, basically we have only access to rotate things on the stack, and they're all of a fixed size. So that's gonna be extremely complicated if we start supporting arbitrary, already supporting structures with type arguments. That's gonna be a nightmare. That's why I'm not gonna be trying to do more actual pointers for this language. And yeah, lowering to AR, I want to do something where, again, we try to be close to the real thing, even if we simplify big for the purpose of this project. And my goal, although the AR hasn't been designed yet, is to try to do something which is a subset of the LLVM AR, with the idea of basically same thing of static single assignment form of the AR, that we could potentially then write a translator into actual LLVM AR to be able to compile our language using, actual LLVM. But with the idea that it mimics the way the LLVM AR works in, again, a lot more simplified, from which we can do the code generation into the bytecode. And the bytecode part is already done. We've done that a few weeks ago. So that's the idea of the project. There is a lot more to do. There's so many parts of this project where I have the rough idea of what it's going to look like, but the details I haven't figured out yet. Incremental compilation, for instance, that's something where for now is kind of very abstract. So it's going to take a few months, if not years, to get there, because I only stream twice a week, and my health being what it is, I don't stream every week. But yeah, that's the project. So this is, I think, with this, it is the correct version of this. We are able to resolve the type without doing necessarily... Yeah, the goal is to try to be, even if we make something that is simpler, again, we have no pointers, we have no heap, a lot of things are simpler by virtue of the choices we've made. I want to treat this with all of the rigor of a real compiler as much as I can. So yeah, some of it is slightly over-engineered, but that's what makes it fun. So here, why do I need to actually do the type alias, analyze type alias? Yes, here is where I need to do the analyze type alias, which is the case where if we have a cycle, we're going to need to detect it. And I guess here is where we would need to detect that we have some self-recursion. The problem being it would be hard to distinguish between we have an actual proper cycle of the type A contains itself versus the type A contains something parameterized by A, which might not be a problem. So I think I'm not going to try to do that for now. Okay. So analyze struct is, yeah, fairly straightforward as a result. Like info is not even required. The name is, yeah, I think, no, I think I want to have the name in scope because we are going to want to do more checks there. There's probably going to be some warnings to emit if the names of the record shadow anything. But for now, there's nothing much to do. So this is just applying the lens on the struct info, which is the values, and the lens, the function we apply is a traverse of the resolve path. And yeah. Except this is not resolve path, this is resolve type, because we are checking that indeed the struct everything is indeed a type. So that should be all. Type alias was really the most difficult. I'm still not sure about the substitution stuff. We're going to have to try. And next, what do we have? So analyze declaration is here. This is the part where I need to replace this with analyze type alias info. Analyze struct info. I'm going to be petty and then vertically align the whole thing. Now, what do we have to do for an enum? Not much, to be honest. Because an enum, it's just basically we have to check that there's no duplicates in the yeah, I think we just have to. Oh, that's something I had not considered. There is a subtlety with enums, because of course there is. With enums, that means that when we do create the basic scope with names, I need to add into the scope. I've had the chance of working on a compiler-like project at work a few years ago, and that was absolutely fantastic. And yeah, compilers are fun. I think I've set the bar a bit high on this one for like a completely alone live on stream project, but where would be the fun otherwise, right? There is a challenge here, which is I am gonna need, whenever I create the scope, I need to put the enum names into the scope. Because if I'm analyzing a function in my module and it makes a reference to red, which is an element of the color enum, I need to know that this red thing points to an enum value of a specific enum. And I have not done that. So that's something we are going to need to do as part of the init of the imported context and the local names. So enums are not properly supported yet. I'm actually going to add a to-do for this right now, because otherwise I'm going to forget and have errors later. So here, and same to do here for the local modules, which is fine because this is purely a mapping from identifier to names, which we can do without resolving yet, I guess. I guess we can do that without resolving, and what happens in the worst case is we create duplicate entries that's just gonna be overridden. And the second we analyze the enum anyway, we're gonna be like, we don't know what that is. So that's fine, I think. I guess we could even do this properly, where if we have different entries, there's more than one name for a given identifier, because there's twice the name red in a given enum. uh, yeah, the code base is. I've tried to keep the structure as if even if the code is not always the best, because again, written on stream with like such a Zoom thing, and not always all the spoons required. I've tried to keep it with like clearly a representations folder with like this is the AST, this is what an image is, and there's the stages that has like the lexing, the parsing and the lexing and everything, like a different module or a different folder, so that hopefully the structure is clear. There's a tiny bit of documentation as well. It's not good enough or anywhere near good enough at the moment, but there is some amount of documentation. And I guess, yeah, if we have two red, we'll have two entries of like, hey, the identifier red maps to this name, which is part of the enum. And as a result, there's going to be, if we try to make a reference to red, we're going to get an error, which is like, hey, this is ambiguous. Which of the two reds in this enum do you mean? And we're going to have an error for the enum itself, which is like, there's more than one entry of the same name. So that should be fine. Okay, so therefore, analyze an enum. So here, what do we have to do? We don't have... We only have, I guess, at this point to check... We only have to check that there's no duplicate. I guess that's basically it. There's not much else to check on an enum. Because the fact that the identifiers are well constructed is something we already know just by virtue of the fact that it has parsed so far. So I guess I could just, what's an enum info? Let's look at our AST. That's just enum values, which is a list of identifiers. Which means I can do names, which is going to be the group of sort of the enum values of the info. Let me just check something quickly in GHCI. If I do a group of sort of A, B, C, and A, I'm expecting to get, okay, I get a list of lists, and now I can check that none of them has a length greater than 1, basically. And that is going to be, basically, how did I do that? For local names, let's see. Yeah, I simply do an or. Yeah, I'm going to do the same thing. For names, we get a list of identifiers that have all of the same name. And to each of that, for each of that, we are basically checking that the list is only containing one element, basically. So here, if it contains only one element, that's a list of one element, there's absolutely nothing to do. I guess I could... Yeah, let's do false. Let's do failed. So false, it hasn't failed. If it contains literally anything else, which will not be an empty list by virtue of having using grouped, then we can do a tell to signal a diagnostic, signal an error, but that way we can signal all of them at the same time. And pure true, it has failed. We do an or on the result, so we get failed. And when failed, short circuit with M0. So now we need a new error for error enum multiple duplicate names, duplicate entries. Has that been done? I mean, there's no reason you couldn't do that. Should you is another question, but could you? Probably. So that would be the name of the enum, and that would be a list of identifier. I guess it's just one identifier. I don't need more than one. And here, therefore, it's an error enum duplicate entries, the name of the enum, and which identifier is wrong is head of names, which will crash and panic on an empty list, but we have used group right here, so that cannot be an empty list. Okay, when failed, M0. And otherwise, we return an enum info resolved, which is a different type, but it has exactly the same stuff, which contains enum name and enum values. Okay. So we've done type alias, struct, and enum. What kind of declarations haven't we done? Constant and function. So this is an enum declaration of analyze enum of the info. Okay, let's do constant next. Which is going to be the same thing of constant declaration of analyze const. What do we need to analyze a constant? Here we can use our constant thing, our analyze declaration thing, because constant cannot perform cycles. There is no way constant can perform cycles. So if we have a constant A that depends on B that depends on A, or that depends on B that depends on B, our stack thing will take care of that. Oh, there's a mistake. There is a mistake in our code. Here I am setting the stack of like, hey, we are currently analyzing this type so that we are able to see the stack of things we're analyzing so we can detect cycles. However, I never modify the stack back to indicate that we're out of this. That suggests to me that the stack should not be there. It should be here. It should be here so that we can perform a modification to it and have that modification be scoped to the sub-expression. Which means I have to change this here to SMT and remove it from here. I think I will need set stuff here, and I did not import it yet. So let's do that. And that means in my analyze declaration function, when I'm checking the stack, this is no longer context stack. This is view s info stack. And here, instead of being a modification of the state, this is equal to local. And that is the info stack is modified to insert the name. And now, when this block returns, local is finished, the reader the reader is restored to what it was before. Therefore, now we no longer have to manually maintain this stack, which is represented as a set. That's fine. Okay. So what is in a const info? It should probably just be name and value, I suppose. Type and expression. Okay. So I guess we just need to resolve the type. Okay. And that's going to be the const type of the info. And then this is where it gets tricky. We are going to need to basically do, well, not constant unfolding in the sense of like, as we will do it in a function, but we need to basically fully evaluate this constant at compile time, which means everything in there needs to be possible to evaluate. That means no function calls, because we have no notion of const expr in this language. That does not necessarily mean no. That doesn't necessarily mean no struct expressions, because we could have a constant of a given struct type. The problem of how do we represent that particularly on the stack is going to be pushed to later in this project when we lower into the AR. So I think this is purely a matter of making sure of evaluating the expression, basically. And I guess we need to check at every level that the type of the expression is correct. This is something I've been thinking about. If we look back at the AST, the resolved version of an expression is just that, the expression with the location gone. Do we want to have the type information there? Like, this has been the resolved version of the expression. It now contains type information. I think probably. I think every expression should be associated with a type, and that's the easiest thing to do, I think. So that'd probably be with type expression resolved, and we need to define what with type is. And I guess with type is just has a path info resolved as well. I'm going to copy in location. There is this with location. I'm going to copy it here. Where the lens is declared, they're all declared at the end. Okay. So I think I'm going to do the same thing here. Could they just say that this is like something else, like a typed expression or something? Or do I have anything that's going to conflict with this? I don't think I have. I don't think there's going to be a problem with this. Let's try it. So here I can just replace with typed expression. And typed expression doesn't need to be declared here. It can be declared in the resolved version, which we don't have. It's fine, I'm going to put it here for now. This is a typed expression. And the type of the expression is going to be a path info resolved. And this is going to be an expression resolved. Okay. Is that correct? And this is not the proper lens. The proper lens is going to be... Oh god, I can't declare the lens here because I would need this to have a lens, which is only going to be declared later because template Haskell. That means I probably want this thing to be declared in another module just so that... but it depends on the expression. Template Haskell may be hated. The problem with template Haskell is that it forces the order of declarations in a file to matter, which is not the case by default. So if I want to use the make lenses thing to generate the lenses for me, like I do here, that means anything that uses the lenses needs to come after this, which is a tiny bit annoying. Just a tad. Which was fine for everything because all of those lenses are not declared within this file. But here, I'm going to want exp value. And that is something that is not declared at that point. How do I solve this? How do I solve this in an elegant fashion, I should say? Because there is a very easy way to solve this, but it's ugly as hell. And that's why I don't want to do it, which is to put all of this at the end of the file. Just put that at the end there. After doing a make lenses typed expression. There we go. That works, but that's ugly as hell. The thing is, I don't see any other good solution for now, so I think for now I'm just going to do that. And add a comment explaining why I'm doing this. add make lenses for the type expression. And here, not lenses, but okay, that's ugly, but at least that should solve it for now. So, back to here. So we resolve the type, and type is a path info. Then we resolve the expression by calling go on the const value, which is going to be a const specific expression evaluation. And here we're going to need to check whether the types match. Like, what's the type that we have inferred from this expression? Our type resolution is going to be fairly straightforward because there is no construct in the language that might give rise to something ambiguous, I think. So we can always infer the type of an expression just by looking at it. So I guess here it's going to be something like when resolved type is different from the type of the resolved expression. Report fatal undefined, but that's an error. Like, hey, this expression has type int, but was declared as having type string, or something like this. And we can return a resolved const info with the resolved. Actually, I'm just gonna do it like this const info. There we go. It's gonna be const name, resolved type, resolved exp. Okay. And now is where we are going to do a big case on an expression, which I guess I can copy this case here. There we go. And here is where we're gonna need to check that we're basically gonna need to do a resolving of the expression, but with the added context of being in a const. What I'm supposing is basically that what we're gonna make here for constants, we can then generalize to resolving any expression, and the only thing is, I think we'll only need to parameterize resolving a path, as in a name, because that's the only thing for which we are gonna need to that's the only thing for which we're gonna need to basically change what we do based on what we are. Because if we are in the function, we can call functions. If we are in a constant, we can only call constants. So I think that's gonna be the only change. But we can write it as it is for now, and 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 generalize it to any expression when we're done. So path expression being the most complicated, I'm gonna skip it for now. So for a cast expression, we're gonna need to check that the types are castable. And that's not something that can be overridden, that's something that's built in. But that's probably not something we want to hard code at this point. So there might be something we include in the built-in module of like, hey, can this type cast to this one? And I guess the only thing we want to be able to cast is gonna be from int to character, from character to int, basically. And from vector of something that is castable, from vector of int to vector of character, something like this, because that basically mean something that has the exact same number of spots on the stack, basically. And a vector will always be n plus one cell being the size, and then all the other cells being the elements of the vector. An int being just an int, a character just being one int as well. Those are easily castable. Yeah, I think that's basically it. This is going to be basically a can we cast this type to this type check. So we resolve the expression recursively. So go for the expression. We resolve the type by doing a resolve type of t. Then we need check can cast e to t, which we don't know how to implement yet, so that for now it's going to be a comment. So for now, we're always going to accept the cast. And the result of this is going to be a typed expression. Where the type is going to be the resolved type. And the value is going to be the exp value of the resolved expression. So we are keeping this as a cast. So I guess I should keep this as being a cast expression of this exp value to... No, because... So we're returning an expression... Yes. The cast expression contains the full resolved expression with its inner type and the resolved type. But this is wrapped in a typed expression with now the proper resolved type. There we go. Okay. Field access expression, that means we are going to need to check that the type E is a struct and that it has a field with that name. Call expression, that's going to be very easy in the context of a Actually, what kind of error do we want to do here? Let's have a look at the Rust playground, which I'm going to put here so you can see it. What if we have... What's the syntax again? Const x, which is an I32 equals 0. That should be fine, right? Except foo and bar no longer exist. What is this? Print x, something like that. My Rust is must be a string literal. Okay. What I want to check is if this constant contains a function call, will it error upon realizing it's a function call regardless of whether the function exists or not? Or will it first tell me, hey, this function doesn't exist, before actually telling me, and by the way, you cannot call it? Probably the latter, because Rust has const exp functions, so it needs to check that whether the function exists first to be able to tell me whether it can be called in a constant, I think. Oops, yes. Cannot call non-const function. Yeah, it has to resolve it first because const exp function exists. But since in our language they don't, I think it's probably fine to not even attempt to resolve any of this and just immediately just report fail, like, nope, you're trying to call a function in a constant that doesn't exist, doesn't make sense. For an array expression that's going to be something hard-coded, we're going to need, oh god, we're going to need to have some notion of a built-in array vec type that we don't have yet. So that means to finish implementing this, we are going to need to figure out how we represent built-in declarations. So undefined for now. Similarly for the index expression, because that depends on the expression on the left must be a vector, the expression on the right must be an int. So this depends a lot on knowing how we represent specific built-in types. A struct expression, however, should be doable. And I'm probably gonna not maintain the vertical alignment because each of the K's is gonna be different. So there's no point in trying to vertically align all of them when there's gonna be so much that changes from one to the next. It made sense when they all fit in one line, but here they won't. Which I guess I could do with the regex, but that's fine. So, what do we do for one struct expression? I guess we need to simply check that this type is indeed a struct. So resolved type is resolve type of this path info. That's what it takes, right? Wait, where is it? Wait, did I? Oh, there it is. Result type, path info, perfect. Then from this, I need to do an additional. Huh. Do I want to duplicate this function with more specific things? For instance, I want to do a resolve struct, which is the exact same thing, except I have to do this additional layer of I think I don't want to duplicate all of this. It feels... Although I guess I could provide... Yeah, I should probably provide a resolve struct function that does the same thing and like... resolve struct. And basically I make a resolve path function that takes as an argument a callback to deal with the declaration. Yeah, I think that's the proper way to do this. Okay, so let's actually just so resolve path. It's going to be that. But resolve path is also going to be taking a callback function f, or just callback, or process declaration. There we go. And that function, that callback, will be something that, given a declaration passed, will return something in this monad. And that is now replaced by... Actually, I think I'm going to give the arguments in the other order because it's going to be easier for the functions above. So now this is going to be retrieve declaration of the name and apply to that, bind that into process declaration. And resolve type. Actually, no. Okay. Is resolve path. And the function we're giving it is a backslash case of this thing. Okay. And so resolve other struct is going to be very similar. Except nothing will not be acceptable because we always want to have a declaration for something that is a struct. So this is going to be some kind of error. And if we get a type alias, what do we do? This is again the problem of the recursive nature of type aliases. Okay, so here is where this is wrong. We are gonna need to recursively. Yeah, I think in both cases, the way we handle type aliases is wrong. So for now, I'm just gonna make a big undefined here in the case of a struct, because we need to not just return the type info like we do here, we need to actually recursively solve it. Yeah, I think this is wrong. I think in both cases this is wrong. Okay. So we're gonna have to rethink type aliases, I think. So for now, I'm gonna comment this out because I think this is inaccurate for now. Okay. Anything that is not a struct, this will be an error, not a struct or something. And when it is a struct, then I guess we still need to do that. So I think this is duplicated, which isn't great, but that's not the end of the world. Okay. So now I can do resolve struct of the type. And then the fields are sub-expressions, which means I need to traverse go resolved fields. Let's traverse go the fields. And here we're going to be rebuilding a struct expression with resolved types and resolved fields. There's probably more to do here because we probably want to check that the fields are correct, like the names are correct. To do check field validity. Because what is in an expression for a struct expression, this is a non-empty list of identifier and annotated expression. Okay, so yeah, we are not going to be able to just do a traverse resolve. This is going to be a for each of them. Is the identifier mapping to the thing? Do we have duplicate identifiers? Can we resolve the expression? Does it match the type of the field? So there's a lot more to do here. Okay. At least this is easy. A Boolean literal expression is going to be always a type expression with undefined, which is going to be our representation of the built-in Boolean type and the Boolean value, which is a literal expression B. Okay, all of those are going to be the same, so I can copy them here. Here, there's literally nothing to check. A Boolean expression is valid. A literal int expression is valid. That is all fine. So this is just how do we represent this internal like Boolean type and other built-in types. And here I just need to copy this. A reference expression does not make sense in the context of a const. They are only used for function arguments. Therefore, this is always going to be An error. I was going to say, unless it's in the function argument in the constant, but there cannot be function calls in the constant, therefore a reference expression will always be wrong in a constant. That's easy. What I've done here for the cast expression is wrong because I'm going to need to resolve the expression. Therefore, at this point, I will need to transform a character into a Boolean. Like, I will need to basically transform whatever the underlying value is into a actual. I'll need to actually do the cast at this point because I'm resolving the constant at compile time. So this is wrong. And I guess since this is always built-in values, yeah, it's gonna need to be hard-coded here at some point anyway. Okay, reference cannot exist here. Negation expression is going to be so I get a resolved expression by doing go on the subexpression. To do check that the type is int. I guess that's basically I do a case on the thing, and if it's not a int literal, then something has gone wrong. And if it's an int literal, then I can just do minus. And I guess that's the same thing for all of the others. This is basically going to be, okay, recursively resolve the subexpression, check their types, and then perform the actual operation if it makes sense. So if it's an int literal expression x, well, if it's a typed expression with a type t that I don't care about and an int literal expression, then the result is pure of a typed expression. Actually, the type I really don't care, so let's do it that way. Typed expression type t I don't care about. Resolved is the result of going go e, and then I do a case of resolved of, and if it's an int literal expression, I can do something about it. Pure, this is gonna be this appended at the beginning of this, and that's gonna be pure of int literal expression of minus x. If it's literally anything else, I guess I could try to have like, oh, expected int got character, like handle the other cases properly. But otherwise, this is going to be a report fatal because that's never supposed to happen. Because all of the others should have returned the proper. Like, all of them should return a literal, and if they don't, we should handle the error properly. Oh, I guess not all of them. They could be a struct, I guess. Yeah, I guess they could be a struct expression or something. But basically, we're going to need to be able to handle all of those cases properly here. God, this is going to be a nightmare. It's going to be super long. So we recursively evaluate the constant for those two sub-expressions. And then typed expression T1, which is because it doesn't matter. K is resolved E1, E2 of if they are both int literal expressions then it's the literal expression x plus y. And otherwise, we're going to have to handle the different types. If it's two characters, characters plus int, that kind of stuff, string plus string. Okay, and all of the others are going to be the same. The thing is, I'm starting to be really tired, so I think I am going to just, for this evening, check that what I have so far compiles. And I think take a break because I am starting. I started with very low spoons, and I'm starting to feel that they are getting low. Although I guess the assignments are going to be very easy because all of the assignments are going to be unavailable for a constant. So that's very convenient. Where's that emote? Oh, it's a frog. Took me a second to pass it. I thought it was Eskia from Expedition 33 for a second. And yeah, I'm gonna put all of those as undefined just for this evening, just to see if this compiles. Okay. That's roughly the shape that this is gonna take, but this is gonna require having a tiny bit more spoons than I have this evening. So I think for this evening, I want to check that what we have done actually compiles. Which it will not at first, so let's do that. Okay, no instance for show. Annotated expression resolved. Oh, do I need to? I probably need to do deriving instance show constraints. Why do I have functor? That's wrong. Show constraints of resolved show type expression, I think. Oh, and where I had functor, that's because I copied this from with location. Okay, so AST compiles, that's good. That means our ugly solution earlier for the problem with lenses of putting the thing at the end here worked. That's always good. Expected kind. Oh, because enum info is not. Yeah, enum info doesn't contain anything that is specific, which means on success, I can return the row info unchanged because it is not specific to a given phase, because none of its information is. Yep. And this is a const info. Not in scope locations. Ah, this is something we have changed. This is annotated declarations. Oh, why has it changed? because this top level names is yes, this entity declaration is in non-empty list. Okay, so that's correct. Yeah. Entity declarations. I must have renamed it at some point. I didn't remember that. And scope name, I think it's called this name in scope. Yep. Resolve path info is no longer something that exists. Because I have resolve type or resolve struct. This is resolve type, I think. It is, yeah. And this is again something where, like, for type aliases, what we do is incorrect. Const value. So it's not called const value. What is it called? It's const exp. Okay. This is not struct exp. This is struct. Wait, no, it is. What do you mean? Data constructor in scope. If I go back to expression, yeah, this is called struct exp. Did I typo it? No, that was fine. Oh, yes. Oh, I'm gonna have this a bunch of places. Okay. Oh, yes, of course. This needs to be typed. Therefore, this needs to be a typed expression of the resolved type. Except in the case of a const. No, I think that's correct. The good news is we're already at the point where we're making the last bit of this evening compile. Aha. So this needs to take the parameters as an argument, I suppose? Yep. Because this already... Okay, so I need to rewrite this as being this of go, where... not just front end. I mean, we're still technically in the front end section, but full compiler, yeah. This is the analysis phase. So we've already passed the AST, we've resolved, so we have the fully passed AST. We're doing the type checking and the name resolution to get like the solved version of the AST. After that, the next step will be lowering into the AR. This project will not convert into assembly because this project is a bit different. Rather than lowering after getting the AR, rather than actually converting to assembly, we'll convert to something else. Specifically, our target is an esoteric programming language named Piètre, in which the source code is an image. So the output of the whole thing will be generating images like this. I've already done the assembly part, which is like from the code generation part that generates bytecode making an image. That part is already done. but lowering into the AR and then generating the bytecode, that's not done yet. Yeah, it's an esoteric language which is not meant to be used seriously, but yes, it is. It's called Piètre. It's fantastic, and this is a generated program from bytecode that just prints like two characters to the output and returns. But you get it's written PIET. It's let me show you if I extend this window a tiny bit so that it's more visible. This is the that's not how you like as a first message on my channel saying that stating that Java is better than Haskell is a choice you're making there. But yes, this is Pete based on the paintings of Piet Mondrian. And the logic is basically the transition between blocks of colors encode the instructions. And it's a very limited language. And there's only like 17 instructions, and they're all basically based on like the color transition, and they're all stack based. We have no heap, which is why the language we're compiling is a fairly simple language because, well, fairly simple. It still has like a few interesting things, but it's still limited by the fact that, again, no heap, purely stack manipulation. But yeah, welcome everyone. I was about to stop for the evening, but so your timing is perfect. I was just making that the changes I've made this evening are actually compiling. So again, to sum up this evening, Lexer parser that's already done for a while. The linker assembly part that like from bytecode makes the image done already. Now we are doing the hard part, which is the analysis, the name check, like name resolving, type checking, and so on. And after that, when that's done, hopefully in a matter of weeks, we'll start doing the lowering into IR. And that's going to be challenging because I want to target, like, again, the language we are compiling is a subset of Rust, like much, much simpler, but based on Rust. I want our IR to be an SSA IR similar to the LLVM one. Again, a lot simpler than the LLVM one, but based on the LLVM one, with the idea that that way we could also not just create an image, but also export to the actual LLVM IR, and from that actually compile the binary. So we could compare the implementation of running the Piètre interpreter on the image and running the actual binary passed from the LLVM, compiled from the LLVM IR that we would have generated ourselves. So that's the project. I was making this evening some progress on the analysis phase, trying to do like type checking and name resolving of declarations of types, structures, enums, and so on. I haven't made as much progress as I wanted, partly because I am tired this evening, and some of it is fairly tricky, notably type aliases that contain type aliases with type arguments. I have not yet fully figured out how to do that. So for this evening, I'm going to make sure that this compiles, and then that's up for the evening. So here, I just need to finish making this compile. Which was my resolve functions that take a path to something and check. It is a somewhat ambitious project, but I think it's interesting, right? Like I have no deadline for it, which is extremely rare for a project. It's if it takes 2 years, it's fine. And as a result, I'm trying to take it as seriously as I would any other compiler project, basically. Like I'm using Haskell. I'm using Alex and Happy, which are the Haskell equivalent of like Lex and Yak and so on, like for parser generator to like use the actual tools that are common for this. I'm using a subset of Rust as my made-up language. I'm targeting the like a subset of the LLVMIR. I'm trying to take this as a serious project, even if the end goal is, images. So here, those were my functions that are given a path to something. Like I'm just here as like, I have like this a.b path something. This needs to be a type, or more specifically, a struct. I have this resolved type. I have this resolved path function that takes a callback to, okay, we've found what this name points to, and then is that an actually a proper type? How do we deal with the actual declaration of it? Yeah, that's the downside. Is I do also all of the advent of code in Haskell every year, and with the advent of code streams, my goal is to try to showcase that Haskell is a very approachable language. With this project, I'm not sure I'm able to showcase that Haskell is very approachable, at least not with every part of the project. I think the assembly linker phase was very, very approachable Haskell. This part probably a tiny bit less, but I will try to keep it as approachable as I can. Because I will die on the hill that Haskell is unfairly maligned and a lot more approachable than people give it credit for. And I want to do my part in showing that it is a very practical and approachable language as much as I can. I don't know how good of a job I'm doing at that, but that's my goal. So here, if I'm trying to resolve a struct, I resolve the path and I give this callback that given the resolved parameters, look at the declaration. If there's no associated declaration, it means the type we had was a type argument, therefore there's nothing we can do. Ooh, first language that's uncommon. My first was, well, technically TI-89 basic, but my second language in school, my school started us with like Delphi and OCaml, which was a choice. But starting with Haskell must be very interesting. Because like a lot of my approach to teaching Haskell, I used to teach Haskell in the past, has been most people I teach Haskell to arrive at Haskell from other programming languages, arrive from C++, arrive from Java, arrive from like have already a background with imperative programming languages. So a lot of my habits around teaching Haskell is like, okay, everything you know about imperative languages, we're gonna have to rethink a few things there. Having Haskell as a first language means you have none of those bad habits. That's interesting. Like any language, right? Like a lot of people have this idea like, oh, monads are the grail of the difficulty in programming languages. And it's like, you understand multiple inheritance. Multiple inheritance is 10 times more complicated than any basic monad will ever be. And a lot of the problem of Haskell is a reputation problem of like people have this idea of it being complicated, of like, oh, all those complicated mathematical terms. In fact, it is practical, but it has this image problem. And yeah, I just want to do my part in showing that like it's not that bad. I I like Python for some things. For people who are doing purely imperative stuff, Python is very simple to approach, which is pretty nice. What I hate about Python is the environment, the many package managers, the many project managers, the like local environment and stuff. I've heard that the last few years there's been some effort at standardization and that it's less of a nightmare than it used to be. But the work environment with Python has always been a nightmare for me. While the language itself is fairly simple to approach in many ways. Although, I mean, I'm a Haskeller. Having a compiler that will check everything for me and make sure that I'm not making any mistakes is something I miss dearly when I'm back in Python because, it's Python. Still a bunch of undefined here because I have not finished everything I wanted to do this evening. That's fine. We'll finish next time. Resolve struct is this. Resolve type is going to be formatted the same way. Hello, everyone. I think you're partly right. Some of the reputation is the over-engineering and stuff, but I think it's not the only thing. I think a lot of it is also because a lot of people arrive at Haskell from a math background, not a programming background. Which means the second they arrive at Haskell, they start talking about like, unit dilemmas and stuff. And if you arrive from like, I've been doing C++ all my life, what is this complicated math stuff? Oh no. The bit rate I'm streaming at is currently around the 6,000 kilobits per second, I think. I'm basically trying to be at the maximum that is allowed by Twitch. Is is there any issue with the bitrate? That's interesting. That is probably just a that's probably just a webcam problem, I guess, because yeah, my bitrate is supposed to be yeah, I Twitch labels my bitrate as unstable because I'm above their recommended maximum. So I guess it's probably the driver of the camera. Huh. Yeah, I suppose it's probably the driver of the camera that's not good. That or OBS is doing weird things with it. I'll have a look at the recording this evening and I'll try to fix that for next time. I upload all of the streams on YouTube. I have a second channel for just of the uploads. For my main channel, I try to have everything subtitled, but for the streams, since like several hours of unscripted content, I have neither the time nor the budget to actually get them subtitled. So I just upload everything unsubtitled. Also audio compression. Okay, that's very weird. But thank you for telling me. I'll check for next time. I'll look at the stream. I'll look at the recording of this stream and see if I can fix that. So here I was just finishing cleaning this. So here is, okay, we have a path and we need to know exactly what type that is. And here is the case that we don't handle properly, which is we haven't counted the type alias. Like, oh, I'm naming something that is foo. What is that foo? Is it actually, what is it actually? And we need to actually resolve the thing recursively. Well, yeah, thank you for dropping in. I'm trying to stream every Tuesday, every Thursday. I can't always make it, but that's my goal anyway. But yeah, I have checked your channel. I'm happy to see more Haskellers on Twitch. And here we're trying to get a type. So if we find a constant or a function, then we can just signal that it is an error. If it's an enum, that's fine. We just need. So yeah, thank you again. If it's an enum, we just need to check that the parameters are fine. Same for the struct. Okay, so that should be fine now. Name not in scope. Aha. So I guess this resolve path, the callback will need to take as argument the name as well. So this is going to be process declaration, name, and parameters. Which means here, that's going to be name and parameters. And here, this is name and parameters. There we go. Let's go path. I'm going to need to have it in scope. Okay, what else are we missing? Context names. Yes, that's because I have changed where the lens is. It's not now info names. Looks like it was the last error. Couldn't match name with non-empty name. Okay. So one of those two things in its local names is returning something that is the wrong type. Oh, no, okay. This is because here within our scope, the mapping from identifier to name, as in within this scope, the name X means this specific declaration there, is a non-empty list because there can be more than one. which we do because we want to be able to report errors of like, hey, you've said X, but which X do you mean? So that means that here, when I do my local to modify to modify the scope just for the sub expression, I need this thing to be a hash map from identifier to non-empty list of name. However, here in both cases, this is just a hash map from path to name. Which actually, is that correct in both cases? Imported scope. I don't know if that's correct because it's a hash map from path to non-empty. Yeah. So this is incorrect. This is a hash map from path to non-empty name. And I guess the easiest thing to do is here for local names to do the same thing. This is a non-empty list of name. Meaning that here at the end of this function, when we have computed the local names and we are missing the enum names, this needs to be we are already making this a non-empty list. Okay, so those are non-empty lists. Perfect. So it's just that the type declaration was wrong. And here that means I am indeed modifying this info names by combining with foreign names and combining with local names, which is a union of the maps in which the values which are non-empty lists are combined with the semigroup operator. That should be fine. Oops. Okay. Oh. Map is for lists, and this is a non-empty list. Oh, this is already... Huh. Interesting. So at this point I've already... Oh yes, here I have already... From the annotated declaration, I have already unwrapped the thing to only keep the declaration, which means here I don't need to do that again. This is not an annotated declaration. This is purely a declaration. So I don't need to unpack it anymore. Okay. Ah, yes. Here, this function needs to return a tuple of the identifier and the declaration. Here, I am doing this on nothing thing to associate a expression to evaluate if this thing returned a return nothing, but that is not enough. I guess it's annoying that I need this. The thing is, I only need this because of the way I'm constructing my hash map. That feels like that feels inelegant. Yeah, because here I'm iterating over my hash map from name to declaration. But I guess I can just do the identifier here from the name actually. From the name, but I can't guarantee that I have the name. But my point is I can do this at the top level. I should not need to do that here. I'm going to remove this identifier here, which means this uses here is going to be correct. And I can remove this let identifier here, and I can remove this pure identifier here. Okay. That means that at the top level, I'm going to have to do something slightly different, which is going to be for every declaration in mod declarations, I have the raw declaration, right? When I do this, because the argument that I'm going here is a with location declaration passed. Yeah. Okay. So for each declaration, what I can do is get the resolved declaration by calling analyze declaration of that declaration. Let's be explicit. Then I can get the identifier by getting, is it declaration identifier? It is indeed, of the declaration. And return pure identifier, resolve declaration. And there we go, except I need to run maybe t. This. Actually, no, I need to run maybe t this whole thing. That way, I only get a value if all of those steps returned, like none of those steps returned a nothing. And then I can sequence all of them, which means I only get a hash map if this whole thing, or they all, none of them return nothing. Okay, that should be better. Okay. Yes, those are all with location. Wait, analyze declaration takes the name. Okay. Why does it take the name? I guess it's useful for, yeah, it's useful for a bunch of things. Okay. I guess I could do a lookup of the thing, but that's going to be a bit ugly. I already know what the local names are. They're always going to be top level declaration identifier. So I guess this is not very elegant, but I am going to just remake this here. The declaration name is going to be top level declaration module name pum mod name. Oh, this name. There we go. And as a result, resolve declaration will be analyze declaration of the name and the declaration. There we go. Now, this is because this is a with location, and I am operating on something that is not with location, which maybe I should change. Maybe it would be better to actually be dealing with... Oh wait, no, I am dealing with something with location. Which means this is the problem. Located. Okay. What now? I am not giving the right amount of arguments, probably. So analyze type alias. Ah, they all take the name as well. Okay. So this is for all of them. Wait, why do I get the module name? I don't need that anymore. So of all of those, I need to pass this name as an argument. It's a bit ugly with the reduced window size. Ah, yes. This is gonna be a maybe of with location declaration passed. Ah, which means there's a bunch of places where I'm assuming that after a retrieve declaration, I have. So that's gonna be wrong. Yes, this is not in the monad. This is purely in the least monad. There we go. Cannot match text with non-empty identifiers. Yes, so this needs to be a path. So purely this identifier. This needs to be a non-empty list of possible values. Pure true. Okay. So here is another example of go expect something that is an expression, while in fact it is not. So I think I need to rewrite this as go is the one. It takes a with location expression and it does what we do for a declaration, which is local update the location for error reporting purposes. And what it does then within this modified scope is do a case of the located thing, which is the expression. And we just need to move this by 4 spaces. Couldn't match. What is wrong? Did I name this the wrong way? So exp type is the name of the field that, given a typed expression, gives me the path info resolved. So if I go here and this returns to me a path expression, that suggests that this name is overloaded. Or go is wrong. That is also a possibility. I'm expecting go to be a with location expression past, and to be something that takes that and returns a maybe t analysis m of a typed expression. Did I do this wrong? Oh, interesting. So go doesn't give me an error there. Oh yes, go located is now incorrect because go does the proper setting of the sub-expression. So all of those located go away. Okay. Now to understand why this is wrong. Because expert type is applied to too many arguments. Arguments. Why would that be? Oh, because resolved type instead of resolved type. There we go. Okay. Expected name to declaration passed to maybe okay. Oh yeah, I guess this is wrong. Wait, no, that's not incorrect. Path info resolved. If we go back to the AST, a path info is something that depends on the AST phase, and in the case, it's name type of P, which means it is a name in the context. So a path info resolved, this should indeed be path info name and params. Ah, but that's because the path the AST phase is ambiguous. Interestingly, it expects this to be a list, which I think is wrong. Yeah, something is wrong no matter what. Okay. Oh, expected name declaration, so it's missing the parameters. Something is wrong. Oh yeah, because here I have forgotten to include the parameters in the type of the callback that resolve paths expect. The parameters are going to be a list of path info resolved. I guess both combined, that is just a path info resolved. So I could just simplify it that way. Ah, that's fine. Let's keep it separate for now, it's going to be easier. At the price of being a bit more verbose. Ah. Sometimes the undo module messes up with the window layout. That is slightly annoying. There we go. So now with the type being correct, here those functions should have the proper type now. don't, but we're getting close. Expected name, path info resolved, declaration passed. Okay. So is it just that here the type of the declaration is ambiguous because I have a bunch of undefined? That is probably what it is. So, oh wait, there's more errors. Could it be that? No, it's in the other one. Okay. So that means I should probably just here make it explicit what the type is. Okay, that should be fine now. And now we should be at the last error of the evening, hopefully. Nope, we're not yet. Oh yeah, this is a maybe declaration passed. That's why. I guess this is not here that it needs to be changed. It needs to be changed here. Because there might not always be a declaration. So for now, we need to handle that. Okay. This callback type is monstrous, but that's fine. Now, are you happy with this? No, not yet. Expected name, path info resolved, maybe declaration passed. Aha, I have something here that returns the wrong thing. Yes, here I have something that returns pure name. That is incorrect. I can probably now remove this type declaration. I can here just return pure path info name params. Okay. Okay. Couldn't match expected type diagnostic with list of diagnostic. Yes, report fail error. It takes one diagnostic to report, none a list. But I guess there would not be any harm in reporting a list of errors, but this expects a path info. I should probably just... Okay, I'm just gonna do it. It's gonna be easier. This is just a path info resolved, so I'm gonna simplify this. And this is a path info name params. There we go. I'm gonna make this into 2 lines like this. Now, that means all of those functions are now taking a path info. So here that becomes pure path info. This becomes path and name. I think this is path info. I guess I could just keep it path. That's fine. And so here this becomes path params, path name. Pure path. Path params. Path name. And path. Okay, that's simpler now already. And I think the same thing will be needed here, except it's going to be a lot simpler, because for now there's a lot of stuff left undefined. So we only need here This is path params. This is path name. And this is the path. Okay, are you happy now? Both of those are path name. Oh, expected path. Oh, I have something that that's the original path here that I have shadowed with this. Original path. Original path. Okay. What is wrong now? Aha. What I want is the actual path within. Okay. So that is. Oh god. I'm gonna introduce an alias for it. It's gonna be a lot easier. So I can just say that, keep it path, and say the original path is path name of the path. There we go. That's not great naming because I'm shadowing a bunch of things, which is not great. But now at least this is correct. Okay. This needs to be in a do block. There we go. Retrieve declaration name piped into process declaration path info name. The name is. Where's the name coming from? Yes, that is the proper name. Aha. When I do resolve them, they contain their declaration. So this is a with location declaration passed. Which means I probably want to handle the location at this level. Which means it's probably enough to just do. Actually, no, I'm going to remove this with location here. So this is going to be with here located to extract the location information. Ah, of course. Fmap located, because there is a maybe. Okay. Now, I'm doing type comparison, and there is no equal instance on the path info. I don't want to do that this evening, so that gets commented out. Because I'm gonna need, if I do add a equal instance on that type, I'm gonna have to add it to a bunch of other things, and that's gonna be a bit annoying. Unused matches. Local declarations. Oh, yes. Yes, that's fine. Because that was the way I used to do the loop before. So that is no longer used indeed. Is there a declaration cycle? That's another name for it to avoid shadowing things. This name unused for type aliases, I guess. Probably because we did not emit a single diagnostic in this function. Likewise here, which means when we start emitting them, we'll have some things to use it for. The binding for names, shadows, yes. Name group. There we go. Okay. I know this is a partial function. I am doing this on purpose. I guess I could. Since I have matched the case where the list contains one element, I can match a list that contains a name followed by anything, because we will only ever match this if there is more than one list element, because we've already matched one element, and that removes a use of head. And here I can handle, I can just, I suppose, so that the compiler doesn't complain. If we ever get an empty list, that's an internal compiler error that we don't need to handle gracefully, because we've just called group here, which means group never returns an empty list. So something went extremely wrong if that happens. This name not used, just underscore it. Ah, yes, here it's the massive thing where I have a bunch of things that I haven't replaced by underscore yet. Let's do that. Except this one doesn't need to be. All of those are warnings, but I am... This is a controversial choice, using W error, which while developing is annoying, but for a finished project is good, in my opinion. I guess, yes, this shadows R1, R2. Let's go. Unused. Unused for now. The binding for path hides this one. Yep. Info, path info. Okay. Define but not use info. And I think that's the last one. Okay. The tests are still passing. I think we've sadly regressed a tiny bit, as much as the structure is better now. I don't think we are at a point, since I have commented a bunch of stuff out to replace it undefined. The structure is better than last time, but I think I cannot rerun the tests I was doing last time to check that we are resolving things correctly across modules. I think not as of this evening. I will have to go back to this on Tuesday. I think on Tuesday the big thing is I need to figure out the type alias stuff that I just have not figured out yet. which is in here for resolve type and for resolve struct. What do I do when I find type alias? How do I expand it and perform variable substitution until I'm able to resolve any of the other ones, constant, function, enum, or struct? That's the big thing that I have not done properly this evening. And when that's done, I can also resume working on the constants, which was the big other one, where a lot of it is just going to be a bunch of verbose stuff, but that's fine. We just need. Oh, and the big other thing is I need to figure out how I want to represent the declarations and the information that is associated with built ins, because for now they don't have associated declarations, which means I cannot perform type analysis on built-ins. For instance, if you're trying to do int and you give type arguments to int, at the moment I'm just going to silently accept it. So int of int would be accepted, which makes no sense. Okay. And I think that's going to be all for this evening. I didn't expect to be able to last that long. The stream has been on for 3 hours and a half at this point. And I started saying, I am very tired. I'll make as much progress as I can. I don't know how much I will be. This was non-insignificant progress, so that's better than I was expecting. Thank you everyone for tuning in. I'll update the YouTube channel tomorrow because I think I'm 1 week late on some streams and I need to hurry up before Twitch deletes all the streams. And I'll see you all on Tuesday.